So this is Jeff Hamrick again at the University of San Francisco's Analytics program. I'm going to talk for just a couple of minutes about fitting a logistic regression model in R. I'm not going to talk about the outputs. I'm going to talk about the output in a separate screencast tutorial. So see that other tutorial if you're interested in a discussion of the output. So I've imported into R the marriage happiness data set. Let's take a look at that really quickly. If we look at the first few rows of this data set, what we see is that it's got 4 variables of particular interest to us. An indicator variable as to whether or not you're happy in your marriage, an indicator variable as to whether or not you go to church rarely or you go to church often, a sex-related independent variable, whether you're male or female. Unfortunately, this variable is called female and has 2 states, male and female. One of those states is the same as the name of the variable, which is not particularly good practice for setting up a data set. And then there's number of years of education underneath your belt. So one logistic regression model we could propose would be to regress whether or not you're happy in your marriage against your church attendance patterns, your sex, and your number of years of education. And the command for doing so in R produces a fitted object. I usually call these LM fit for multiple linear regression. Here I'll call it GLM fit. The function call is GLM for generalized linear model, and the syntax is quite similar as is in the case in multiple linear regression. So I could regress happy marriage against church and female and education. I'll note that this is the data set that we're using, and an important new specification that you need is to designate the family of probability distributions that we will use to conditionally model the y variable. That is to say, with multiple linear regression, our belief is that the y variable is conditioned on the values of the independent variable, a normal random variable. That's not the only assumption you can make, however. You could believe that the y variable is conditioned on values of the independent variables is a Poisson random variable, or a binomial random variable, or an inverse Gaussian random variable, or a gamma random variable. So our choice in this case for a logit model is going to be binomial. In the case where a binomial random variable is only over one trial, it can have only 2 results. It's either a success or a failure. And what you're really working with is a Bernoulli random variable then. But, and that's what we need, since we have 2 potential states for our dependent variable, happy MAR. So this is what we need for the function call, and it executed properly, and you can call forth the output with summary as we did before. I'll talk about this output in another screencast tutorial, but that is how you fit a logistic regression model in R.